Hi everyone! In this video, I'm just going to go through Output Analyzer, which is another companion tool to Arena. But unlike Input Analyzer, it's not listed in this Tools menu. So we just need to go search for it on our computers, and we can type Output, and there it is, first one. So Output Analyzer is used to analyze data once the simulation is finished. And I'm just going to go over 4 things that can be done with the Output Analyzer. The first thing is that we can view output data within a replication. So let me just come back to Arena, and I have here model 4-1 that I built in a previous video. However, you can see that I jazzed it up a bit. There are pretty colors and all that, but it's the same model. So first, I'm just going to create a statistic that I can view in Output Analyzer, and I think that I will keep track of the rework queue length. So let's call this RWQ rework queue. And I want this to be a time persistent statistic because I want to see it at every point during the simulation within the single replicate. And we can go build the expression. The expression for this is the number in queue for the rework queue. Okay. And then in order for this to be exported into a file that can be read by Output Analyzer, we need to give it a name here. So let's call this rwq.dat. Technically, you should always specify this file extension .dat, but if you forget, it's not a big deal. Okay, so now let me go check my run setup. I'm doing one replicate for 32 hours, 24 hours a day. Okay, and now let me hit play, and I'm just going to fast forward to the end. Yes, I want to look at the results. Okay, so look at these queues. Up until now, the only thing we've been able to see are the final averages after the simulation is over, the averages over the duration of the simulation. But we can't actually look and see what's happening inside the simulation while it's running. But we can do that now with Output Analyzer. Really quickly, just to show you, let's go here. You're probably used to seeing all of these extra files that get created when you run a model. But here we also have the .dat file that we specified in the statistics section. Okay, back to Output Analyzer. Let's say we want to plot this data. We can select the file RWQ. There's only one replication, okay? And here's the plot of the rework queue length at all points in time while the system was evolving. And if we want to see the data as a table, then we can go to Graph Table. And now I'll be honest, I've had a lot of success viewing within replicate data with this table feature, but I haven't been able to look at across replications data. Either way, let's look at this. Okay. And we can either copy and paste this into some other file, but if we want to be able to view it and access it in some other type of software, we can do that very easily by going to File, Data File, Export, and then we can export this, let's give it a name, we can export this as a .csv file. That's a comma separated values file, and that's a file that can be opened in Excel. So let me create this file, and then we can go look for it and open it, and it looks a little wonky. These don't really look like the numbers that we want to see, but that's just because it's in scientific notation. So let me first delete these first 4 rows, and then we need to separate this data into 2 columns. So we're going to highlight the data, go to Data, Text to Columns. It's going to be separated by the character space. Okay. And then let me change the data type to number. And then here we see the column A is our T-now value, and then column B is the queue length at each of these T-nows. Okay, so now that we've seen data within a replication, we can go and look at how to see data, to view data across replications. So let's go back to our Arena file. And if we're going to look across replications, let's pick a different metric. Let's take a look at part A's average time in system. So let's create the statistic, call it AVGTISA. Okay, this is going to be an output statistic. That is, it's only going to save the most recent value for the average total time. And let's go build this. This is going to be average total time in system for part A. Okay, and then we can give this a name. We can call this AVGTISA. And then just to show you what happens, in case you do this by mistake, I'm not going to fill out the .dat. I'm going to leave off the DAT. So let me go back to the run setup and let me change the settings so I have more than one replicate. Let's do this for 30 replications. Okay, and since we have multiple replications, let's do this in batch mode. Okay. And let's go look at the results. So in this category overview, we can't look at the data from each of the replications, but if we go to the individual reports, so we can go to this entities report, we can see the average total time in system for each of the replications. But clicking each of these files and then going in and retyping this data, this is a pain. This is not how you want to be able to access this data. So let's go back to Output Analyzer, and let's plot it. We can click Select File, and we can't see the data file because it's not saved as a .dat file. So we just need to change this to View All File Types, and there it is. Okay. Since this is more than one replication, we have these two options. We have all and we have lumped. And we want to select lumped because we want to treat our replicate data as a single data set. And here we go. Here's the average time in system for part A for each replicate. And if we were to export it, we could look at it in the table form. But what we can also do here is we can look at the classical confidence interval on the mean. So let's do that. Let's look at the point estimate of the mean of the 30 replicates. And let's choose the file. Okay, lumped. Okay, and let's find confidence interval of, let's say, a 90% confidence interval. And here is our mean and half width and our min and max observed values. That's cool. Okay, we can close this. And then the third thing I want to show you is how to compare two outputs from two different models. So we have model 4-1 open in Arena. Let's go open model 4-2. If you remember, 4-2 is the same system, but we included machine failures and worker schedules and a few other things. But we want to be able to compare these two systems. So let's make the same statistic here in the statistics sheet. Let's, and actually I'm just going to go to the other file and I'm going to copy this row, Control C, go back and paste it here, Control V. Cool. And let's make sure this data file has its own name. We can just add a 2 at the end. All right, and then going to run setup, let's make sure that we are looking at the same 30 replications. It's the same sample size as the data from model 1. And then here we have a different replication length and a different number of hours per day. But we want to compare apples to apples. So since we are running 32 hours in model 4-1, Let's also run for 32 hours here. Okay, and we can play. And no, I don't need to see the results. Back to Output Analyzer, and let's look at the confidence interval for this second data file. Okay, and here we go. We have the two confidence intervals, but just looking at these confidence intervals individually isn't the best way to compare these systems. If we want to compare these systems, then we can go here to Analyze, and we can select Compare Means, and we can perform a t-test. Now, in both of these data sets, we have 30 observations. They're the same sample size, and we know that Arena controls for randomness. That is to say that if we compare trial 1 from the first system to trial 1 in the second system, we can be sure that we're not looking at an average realization of system 1 and some weird outlier realization of system 2. That's what it means to control for randomness. So we can run a paired t-test, which is the first observation of A minus the first observation of B, second observation minus second observation, etc., etc., etc. And this is a more powerful test. It's powerful in the statistical sense, 1 minus beta. So let's select our data files. Okay, and the hypothesis that we're testing here is that the system A minus system B equals 0, which is the mathematically equivalent to that to A equals B. Okay, and here's our confidence interval for the difference in means. So if 0 is in the confidence interval, then we don't have sufficient evidence to reject this null hypothesis. If the whole confidence interval is to the right of 0, if it's entirely positive, then with this level of significance, we conclude that A is bigger than B, and vice versa. If it's entirely negative, as we see here, then B is bigger than A. And that makes sense in this context because model 4-2 should have longer average times because in model 4-2 we have machine failures which weren't in model 4-1. And then the last thing I want to show you in Output Analyzer is how to verify your model against the real system. So let's say we have some quote-unquote real data from the system in model 4-2. It's not any of the metrics that Arena calculates automatically, but the plant manager has given me the scrap rate for the last 8 weeks. Here we go. So let me go to Arena and we can create that statistic. So I'm just going to delete this and create a new statistic. I'm going to call it scrap rate. It's an output statistic, and we can build this. Scrap rate is defined as the number of parts scrapped divided by the total number of parts processed, and the rates are given to us in the units of parts per thousand. So let's think how to do this. We want to say that this is the number of observations from the record scrap module divided by the number of observations from all 3 record modules. First time, okay. And then we're going to multiply this whole thing times 1,000, so we're in the correct units. Okay, and let's give this an output file name. We call this scraprate.dat, and then we can go to the run setup. And since scrap rate is given to us by week, let's extend the replication length to 7 days, and we can run this. Okay. No. And now in Output Analyzer, actually, let's close some of these windows so I don't get confused. Okay, so we can now view the simulated scrap rates in a plot. And we can calculate a confidence interval on the mean. But what we really want to do is to perform a t-test with the real system data. And to do this, we really need to be able to view the real data in Output Analyzer. We need to copy this data and put it into a text file without any headers. So let's save this. We'll call this realscrap.txt. Okay. And then in Output Analyzer, we can go to File, Data File, Load ASCII file. So that's just our text file. Here it is. And then we can give it a name and save it as a .dat file. Okay, realscrap.dat. And done. And now we can just do a compare means test. We can select the two data files, file A, file B. But now, since we have different sample sizes, and since these data sets are coming from completely different sources, we should do a two-sample t-test. Okay, and here we go. So here we see that yes, our model can be verified. Of course, I made up the scrap rate data based on model 4-2, so this is not that surprising. In reality, it's probably not very likely that your first iteration of the model can be verified on the first try. But for the time frame of the class project, it's enough to at least try this once, and then we want you to be able to discuss how you might correct your model to make it more accurate if you were to continue working on it. And well, that's everything you guys should know how to do in Output Analyzer. I hope you guys found this video helpful, and I will see you all next time. Bye!